Hello all, welcome to the subject microcontroller. This is Professor Meenakshi Pancha from Electronics and Telecommunication Department, Parvatibai, Gyanba Muji College of Engineering, Mogul, Pune. So previous lecture we have seen that how to interface the LED to the microcontroller. Now in today's lecture we are going to see the interfacing the push button switches and interfacing of keypad and 7-segment display. So today's lecture we just covering the theory part. So next lecture we will go for all these programming. So let's see the theory about how and push buttons are works and after interfacing what type of things or what things should happen, what things happen here. So let's see. Previous lecture we have seen the interfacing the LED switches and we have also seen with the programming. In today's lecture we have to see how the interfacing the push button switches to the 8051. Here the figure shows us the above figure shows the single push button switch and which is connected. The first one is connected to P1.3 of the microcontroller. In this figure, the single switch is connected to the pin of port 1.3. This is P1 is nothing but port 1. On third pin to the third pin, the single switch is connected and other terminal of switch is grounded. So, as shown in this figure, still there is no connection in between the point A and B here. The point and B is open connection. There is no connection between these 2 points. So when the port P13 pin is read as the input is high, this is because of 8051 port P1, P2, P3 have internal pull-up register. The port 1 and third pin is a read as high because the other ports like P1, P2, P3 are internal pull-up registers. If the push button K is not pressed, if here as shown in figure, if this push button K is not pressed, then this pin is read as a logic high because there is no any ground connection will occur to this pin. So this pin is read as a logic high and there is no any connection. However, K is pressed. However, when K is pressed, however, there will be a connection established in between the terminal A and B and conducting the pin third of port 1 to the ground. And these reading state of the port pin, we can determine whether the push button is pressed or not. In this state, just we are analyzing the push button is pressed or not. If pressed, there will be a flow of current from port pin to ground. Otherwise, if push button is not pressed, there is no any current flow to the ground. The pin, there is a current will be on at a pin itself only. The push button can also be connected as shown in figure 2 here. In this figure 2 here in this fashion, we can also connect the push button such that one line is the input line and other is the output line here. In this one line is input line and other one is a output line here. And let P1.0 be scan the line and P2.0 is the return line. There are two lines in between the push button is connected that is P10 and P20, and that provides the status whether the key is pressed or not. Here these two the pin P1.0 is a scan line and other pin is a return line, which will check the status that key is pressed or not. Whenever key is checked, P1.0 is grounded, and if P2.0 is equal to 0, then key is not pressed. And if P2.0 is equal to 1, then key is pressed, and this method is useful when P1.0 is equal to 1. Then P2.0 equal to 1 for both the condition, that is for matrix keyboard. So this type of configuration will be used in a matrix keyboard. Here what will happen? Key will be checked. If key will be checked, P1.0 is grounded. Whenever the K is to be checked whenever the P1.0 is grounded. If the P2.0 is equal to 0, then key is not pressed. If this P2.0 is equal to high, then key is pressed here. Here this pin is high. If this pin is high, it means the key is pressed. If this pin is not high, then key is not pressed. Whenever there is a connection, the current flow from here to here. This is high is nothing but not pressed. This is 0 is nothing but pressed. This is high is nothing but the key is pressed, because when the button is pushed, there will be a connection will be established between these two terminals, and current flow from port 1 to port 2, and the high signal will be here, so key is pressed. So such kind of configuration used in matrix keypad. The push button can also be connected to port 0, and here seen in this figure, the push button, the port 0, as shown in figure, we have the figure shows that the push button can also be connected to the port 0. And to connect the external 10 kilo ohm resistor at the point B, here we have to connect the external 10k ohm resistor at the terminal B. So let's see, now we have seen how to interface the keyboard, and when the keyboard will become high or low. So such configuration we have seen here. Now we can see the interfacing keypad, how the total keypad will be interfaced to our microcontroller. So before going to that, we have to see some basic of the keyboard and how the keyboard will be operated. So we have to see, before that, we have to see keyboard is a human oriented output peripheral, and which is used to input the data. Keyboard is, what is the keyboard? Keyboard is a human oriented input peripheral device, and it is used to input data or program into the microcontroller. And it consists of a push buttons. Inside the keyboard there may be many push buttons, and those are type of the switch type push buttons are there. When the key is pressed, the microcontroller identifies the key depression and then performs the appropriate operation. Such type of configuration will be available inside the keyboard. When key is pressed, the appropriate operation will be performed, and this is a human in oriented input peripheral device. The input keyboard is composed of a set of the labeled push button switches. Each switch makes electrical contact when pressed. There is a many pins. They are composed set of the label. They are composed inside set of the label, and Each switch makes an electrical contact when it is pressed. There are many pins there. Whenever the key is pressed, the particular contact will be generated inside. The nature of the contact should be reliable and we have long life to feel right. In case of push buttons key, the metal contact bounces few times, hence the voltage across the switches fluctuates and generates a spike inside the signal. Therefore, it is necessary to debounce the mechanical switches. The key debouncing is done through the hardware and software also. Here, so let's see what is the hardware key debouncing. This figure is a hardware key debouncing. It is implemented by using a D flip-flop, or sorry, it may be implemented by using a flip-flop or latch. And this figure shows the circuit diagram of hardware key debouncing. This figure will be shows the circuit diagram of hardware key debouncing. When switch is connected to A, here when the switch is connected to A, here when the switch is connected to A, the output of latch is goes high. The output of latch will be goes high. When the key makes a contact with a B, when key make a contact with a B, the output changes from logic 0 to logic 1. See, whenever the switch connected to A, here the output high output will be available. Whenever this switch is connected to B, there is no low output is available at the output. The output changes from one high to low, and the wiper bouncer many time on contact B, but the output does not fluctuate in between logic 1 and 0. When the wiper is not connected either A or B, the output of latch remains a constant. This is a hardware debouncing. The software debouncing is also the microcontroller. What happened in the software debouncing, the microcontroller wait for 20 milliseconds before accepting the key as an input. When the key button is pressed, so suddenly it will not accept. It will wait for 10-20 milliseconds before accepting the key as an input. After 20 milliseconds, the key is pressed and the key is accepted by the microcontroller. This process is known as a software key debouncing. Then now we have to think how the total keyboard interface with the microcontroller. The keyboard is interfaced with the microcontroller through the input ports. The keyboard consists of mechanical switches, and these switches are arranged in a non-matrix or matrix form. The non-matrix form is nothing but in non-matrix. This figure shows the non-matrix form. This figure shows the non-matrix form. Non-matrix form of type of the keyboard. The key closure is identified by reading the port data, but it requires many port lines. The number of input-output line is equal to the number of the keys here. Here same keys, number of keys are used whenever the same as the number of output lines is there. To identify the key value, the following three functions should be performed. First one is identifying a key closure, debouncing the key, encoding the key to an appropriate code like a hexadecimal, and the above three functions can be performed through the hardware as well as software. As an example, we will see the hardware technique for identification of the key closure. The interfacing is different here. Here what will happen? The all the line from here, those will be connected to the AND gate. So when all the key are open, the NAND gate NAND gate goes low. All, from these lines, all these lines are connected to the single NAND gate, and that NAND gate goes low when all the keys are open. When one of the key is pressed, the output NAND gate will be high. Then the the output identified that key is pressed. If key This is the key configuration. Here the number of keys are using for a particular line, and the key is pressed. Here the key is pressed. Here the signal will be flow. And how we have to know the key is pressed in a pressed condition or in open condition? We are going to connecting all these lines from connecting all these lines. For example, I have considered. So what we are doing here, from these all the lines we are going to connecting to like this. So this is going to connecting one AND gate. So all these lines are connected to single. If any key is pressed here, then what will happen? This will become low. This will become low. If there is no key is pressed, then this will become high. So in this way, we are going to identify the key is pressed or not. This is the way of interfacing the keyboard to the microcontroller. So this method is called as non-matrix method. So now see how the matrix keyboard interface will be takes place. This figure shows the simple keyboard interface. Here one input line is required to interface one key, and this increase the number of keys. When a large number of keys are to be interfaced, this technique is not useful. Here the single key, here one for the one interface, so one key is required. For many interface, the many keys are required. This technique is not suitable when the large number of interface are required. The matrix method is used in such cases so that the number of connections are used. This figure will here in this circuit. In this circuit, the many number of keys are in non-matrix. This is the disadvantages of non-matrix method. Here, the number of keys are required, particular line, the particular keys should be required. So when the number of lines should be required for our operation, the key number of key also increases. So this is not suitable. So instead that this we are using matrix keyboard interface here. Matrix keyboard interface, which is the figure will be shows this is a 16 key arranged in the 4 row and 4 columns. See here, the 8 keys are arranged with the 8 lines. But here with 4 rows and the 4 columns, total 16 keys are arranged. The number of row is named as a row 1, row 2, row 3, row 4. Similarly, the column is named as column 1, column 2, column 3, and column 4. You guys so late. Repeatedly have to take the attendance. So this is the matrix keyboard interface form. Here the total 16 keys are organized in between the 4 rows and 4 columns. In this configuration, we can see there is a no connection is there when key are open. See here. See here carefully. There is a no connection. There is no connection. There is a small space in between these two terminal. There is a no connection. All the keys are in open. All the keys are open. When the keys are pressed, when the switch is pressed, then only the connection established at the particular keys here. See, when this is required, then if it is pressed, then only the connection will be established, and then only the appropriate current flow through the appropriate terminals. If key is pressed, then there is a connection between corresponding row and columns. So such matrix require 8 lines to complete the connections. So, and also if non-metric type connection is used, 16 lines which will require. Here the same configuration we have to connect by using non-metric connection. This non-metric connection, here 16 keys are organized. If I want to organize in this configuration, another 8 lines should be required because there are 16 lines. So 16 for 16 keys, 16 lines are required. So this is not suitable. This increase the number of lines with the number of switches. But in this matrix form, there only a 4 lines should be required. 4 is a row, 4 columns to organize the 16 switches in between the keypad. And this figure shows the interface of matrix keyboard, and it is required 2 ports here, which requires a 2 ports. One is an input port and another one is an output port. This one is an input port and another one is an output port. The columns are referred to as scan the lines and the row are referred to as the return line. The one columns here, the columns are known as the scan lines. These lines are known as the scan lines and the row lines are known as the return lines. When the key is pressed, when the particular key is pressed, the corresponding row and columns are connected. See here, if number of key I have pressed, then corresponding row. So at what row and column in between that key is connected, that is the D3 and D0. the column line D3 and row line D0 will be connected and they are shorted. And if the output of the row is high, if the output of this row is high, if the output of this row is high, then it makes a line of column high and vice versa. See here. If this is connected to VCC here, if this key is pressed and these two become a short circuited, and if short circuited, the high voltage will be flow from this to this, or like this, these two in between there is a current flow, vice versa in between. And the key is recognizable by the data and which is sent on the output port and the input code that is received from the input port. The steps required to identify the pressed key are: first we have to make all the column lines 0 by sending low on all the output lines. From all the output lines, we have to send first 0 by making all the columns 0. Then the key is, then all the keys in the keyboard matrix are activated. Read the status of the row and that is return line. If the status of all the line is a logic high, then key is not pressed. Otherwise, if the status of all the lines is logic low, the key is pressed. So this is the one of the way of identifying if key is pressed or not. First we have to make these outputs are 0 by sending all the column to the 0. Then read the status of the row. After that, after any key is pressed, then we have to read the status of this row. So at particular row, at particular column, the high output will be available and we can identify the particular key is pressed. So the next one is debouncing the key, and we have explained in this part. I have already explained what is the debouncing of the key. Third one is activate the key from the column and making the other one column line is 0. And first we have to send 0 and we have to see all are 0 or not. So I want to activate. Now I want to activate a particular column. So I want to make one column will be high and other column will be low. And then I have to read the status return line. The 0 of any return line indicates that the key is pressed. So I want to check particularly. So make one column will be high and other will be low. If any key is pressed, so it means there is a particular key is pressed on that column. So activate key from next column, then repeat the same steps for each column. This is theory behind interfacing of keypad with your microcontroller. So we can also write the assembly language program for interfacing the keypad to the microcontroller. So writing the program part, we will explain in the next lecture. Today we will complete with the theory part. So in this lecture we have seen how to interface the push buttons and what are the hardware and software key debouncing and key interface circuit that those consist non-matrix type keyboard and matrix keyboard interface. Now programming we will explain in the next lecture and the other theory part, that is interfacing 7-segment display, we will see in this lecture. So the 7-segment display use 7 LEDs. What is the 7-segment display? Here. This is the 7-segment display. See, this is the 7-segment display. This is using how many LEDs? 7 LEDs. See, this is one LED, this is another LED, This is another LED. See, this kind arrangement will be used for display purpose. If I want to display 0, then all the LED will be glow here. There is a 7 combination: 1, 2, 3, 4, 5, 6, 7. See here. If the logic signal, for example, I am considering if there is a start from 0. If all are 0, this means no any LED will be glow. If this combination will be occur at the 7 segment display 0, 0, 0, 0, 0, 1 means the number 1 this kind of LED will be glow. Combination of 7 segment display. We can give the number 1, 2, 3, 4, 5, 6, 7. See, there are 7 LEDs. If for displaying 0, the all LED should be glow. So 1, 1, 1, 1. Active low. If there may be two way. One is active low LEDs are there and active high LEDs are also there. If all are 1, then all the LEDs will be glow. If I want to display, then number 1 and number 2 LED should be glow. If I want to display 3, then these LED should be glow. See here, number 4, number 1, number 2, number 3. This LED should be glow. If I want to display 5, then this arrangement of LED should be glow. That is number 4, number 3, number 2, number 7, and number 6. So such kind of LED will be flow. There are many varieties of 7 segment displays are available in the market. So let's see the theory. This is the symbol of the LED. This is the symbol of the LED here. This part is called anode and this one is cathode. How the arrangement are providing here. So such LED, I have mentioned this LED like this. So we can see name like that. So common cathode. In common cathode type, the cathode of the all LEDs are given at the common pin. So there are how the pin configuration also organized by using these LED. That's also important. Here, what type of arrangement we have considered as common cathode. So this means this kind of LED configuration. So here one LED and another one LED is here. So this kind of configuration, common cathode configuration is this. So this type of configuration, the seventh one is connected like this. These are connecting common cathode. The cathode is connecting to, and in this connection, the 8 should be displayed. The 8 should be display is nothing but all the LED should be glow. All the LED should be glow. All the LED should be. In case of common anode connected, for glowing the LED, the current will be flow across the each LED and the current should not exceed beyond 2 milliampere. While displaying these LEDs, the current should be flow at particular LED to glow at particular LED, but the current should be flow beyond 2 milliampere. The current should not flow beyond the 2 milliampere. The common anode, that is the in the common and in the common anode configuration of all the LEDs are given as a common pin, and in this case what will happen, cathode is connected to the port pin, and hence the port pin have to sink the current 20 milliampere. Hence we use the common anode 7 segment display, and which is used to connect 8051 microcontroller. So in this configuration, the common anode configuration will be using. So this is the common anode configuration. Here what will happen? These all are LEDs connected. The 8, see here 7 LEDs is there and 7 connection is there, and all the LEDs are connected. How the common anode? Common anode configuration is undergoes in this type of configuration, and the name is labeled from A to G. In this type of configuration, the each pin name is labeled as A to G. A, this one is B, this one is C, this one is D, and E, and this one is F, and center one is G. So here A, B, C, D, E, F, G. So such kind of connection will be there. And the another one connection DP is nothing but represents a decimal point. This another one is DP is nothing but a decimal point. By forward biasing the different LED segment, we can display the digit 0 to 9. So we can, by using this segment, 7 segment display, we can display up to 0 to 9. So let's see how the binary configuration will be takes place. The data given to the pin for displaying digit 0. What should what kind of data should be flow? Digit, and here A, B, C, D, E, F, G. For displaying 0, what should be go there? 0, digit 0, 0, 0, 0, 1. This means one, 2, 3, 4, 5, 6. A is low is nothing but this one is glow. This one is glowed. This one, no, this one is not, because we have to display 0. We have to display 0. So G LED should be remain off. This is the common anode type configuration. In this where the 0, which one is high, that one is off here. Which one is 0, that one is low. So all these from A to F will be low, and the middle one LED will be high. Is nothing but this one is off here. This is common anode configuration. Depending upon the configuration, we should decide at what bit it will glow and what bit it will not glow. In the common anode configuration, at the 0 input, the LED will be glow. So for displaying 0, all LED from A to F should be glow. For displaying 8, For displaying it, what will happen here? When displaying it, every LED should be glow. These all are 0. That is nothing but all the LEDs will be glow. A, B, C, D, E, F, G. For displaying one, what LED should be glow? For displaying one, digit 1, what LED should be glow here? This one, B, C here. B should be 0 and C should be 0, except that all should be high. So this according to this configuration, LED will be glow. So such kind of code we have to send by the microcontroller to display. To drive the multiple 7-segment display, it is difficult to spare separate port for each 7-segment display. For example, to interface 4 7-segment display, we will require 4 ports. See here, if we want to display the 4 digit, then we have to connect 4 different 7-segment display. This will be display from 0 to 9. This is 1 digit. This is 1 digit display from 0 to 9. This 1 digit. So if we want to display 4 digit, then 4 7-segment display will be interface, or it should be connect. And for example, to interface 4 7-segment display, we will require 4 ports. That is, all the ports of 8051 will be used. And in this case, no other device can be interfaced to the 8051. And we multiplex the 7-segment display. This figure will be shows that arrangement. Now, to control these 7-segment display, we utilize one of the character of human eye, that is persistence of the vision. We will give the data for the first 7-segment display and enable it by common anode pin, and keeping the common anode pin remaining 7-segment display. The PNP transistor is connected to each common anode pin. So hence we require a 0 volt. So here common anode configuration, what type of transistor is there? There are a PNP transistor. Those PNP transistor will be operate when 0 volt is there. For low voltage, the PNP transistor will be operate. So that we will provide 0 volt to glow the LEDs. Base of the transistor, it will be on, and corresponding 7-segment display will be selected. So this is the configuration how the 4 digit will be connected, and while the programming part we will explain all the things, how at what digit what LED will be glow, we have to consider while the programming part. So this is enough for the day. In this lecture, we have explained the theory about the push button and matrix keypad, non-matrix keypad, and the basic behind the 7-segment display. What type of LED configuration is there? There are 2 types of LED configuration, common cathode and common anode. So for our microcontroller purpose, common anode connection 7-segment display will be used. For displaying 4 different digits, 4 7-segment display will be connected to glow particular LED. We have to provide a 0 volt, because why at the 0 volt they are glowing, that is means the LEDs which is having PNP type of transistor, so those transistor will be operated at the low signal, so we have to provide low signal to display the things or LEDs. Okay, this is enough for the day, so we will continue the programming part in the next lecture.